Hello friends, this is Chandrakant Ghosh. Today I have come up with the same topic, that is process capability analysis. In my previous video I have talked about process capability analysis for the continuous normal data. In this video I'll talk about process capability analysis for continuous non-normal data. So let's take an example to understand how do we do the process capability analysis. For that I have taken 100 data points from an inbound process of a BPO where the average call handling time is 7 minutes and USL is 9 minutes and there is no LSL. And we all know that USL and LSL are given by our client or customer. USL is equal to 9 minutes means no call should go beyond 9 minutes. Now let's see how do we do the capability analysis. For this I have copied and pasted the average handling time data from the previous sheet. For process capability analysis, there are two conditions which your data and process should follow. First one is your data should follow the non-normal distribution, and the second one is your process should be stable. So let's see the first condition, that is your data should follow the non-normal distribution. That means we have to check whether your data is normal or non-normal. To check whether your data is normal and non-normal, we have two methods in Minitab software. First one is graphical summary and the another one is normality test. So let's see the first one. How do we check the data whether it is normal or non-normal? For that you have to copy the average handling time data and paste in Minitab software, and after that you have to follow the stat. You have to click on stat and then you have to click on basic statistics. After that you have to select graphical summary. Once you have selected graphical summary, a new window will open. You will see that the average handling time will be displayed in the left side of the window, and there will be a variable space in the right side of the window, and the cursor will be there by default. If it is not there, then you have to click on variable space. After that you have to double click on average handling time. You will see that the average handling time will be displayed in the variable space. After that you have to click on OK. You will get this graph, and now in this graph you have to see the p-value. If p-value is greater than 0.05, then your data is normal. If p-value is less than 0.05, that means your data is non-normal. Here in this graph you can see that the p-value is 0.005. That means it is less than 0.05. Therefore your data is non-normal. Now let's see another method to check the normality of the data. Again, to get this graph you have to go to stat tab and then you have to select basic statistics, and after that you have to select normality test. Once you have selected normality test, a new window will open. Again you will see the average handling time will be displayed in the left side of the window, and in the right side of the window there will be a variable space. By default the cursor will be there. If it is not there, then you have to click on variable space. After that you have to double click on average handling time. You will see that the average handling time will be displayed in the variable space. After that you have to click on OK. You will get this graph, and again in this graph you will see the p-value. P-value here is 0.005, and again which is less than the 0.05. Therefore your data is non-normal. So one condition is met, that means your data should be non-normal. So by these two methods you have seen that your data is non-normal. Now you have to identify which distribution your data is. following. So to check the distribution, which distribution your data is following, you need to follow these steps which I have written here. That means you have to click on the Stat tab, and after that you have to go to Quality Tools, and after that you have to select the individual distribution identification. Once you select this one, a new window will open. Again you will see that the average handling time will be displayed in the left side of the window, and in the right side of the window there will be a single column space. By default, cursor will be there on single column space, and if not there, you have to click on single column space. After that, you have to double click on average handling time. Average handling time will be displayed in the single column space. After that, you have to click on OK. You will get 4 graphs. These 4 graphs: first, second, third, and fourth. In all the 4 graphs, you will check the p-value. Whichever is the highest, that means your data is following that distribution. Like you can see, the p-value here is 0.005, here also 0.005. You need to check the highest p-value. Here is 0.00, here is 0.003, here is 0.10, which is greater than 0.005. It is following Weibull distribution. Now here also you can see that the p-value is 0.010. Here also you can see that 0.010, which is greater than 0.005. That means p-value is 0.10 is the highest one among the 4 chart. But there are 3 distributions which are having the p-value 0.101. 0.010. Now which one you have to select? You can select any of them, whichever your organization is following frequently. So let's say you have selected Weibull distribution. Now you need to check the second condition. That means your process must be stable, because if your process is not stable, then the capability indices cannot be reliably used to assess the capability of the process. So therefore process must be stable. So to check the stability of the process, you can use individual chart, IMR chart, X bar and R chart, and X bar and S chart. Any chart you can use to check the process stability. So here I have taken individual chart. So to check the stability of the process, you need to follow these steps which I have mentioned here. Again, you have to go to Stat tab, and then you have to select control chart. After that you have to select variable charts for individual. You have to select the individual. Once you have selected individual, a new window will open. You will see that average handling time will be displayed in the left side of the window, and in the right side of the window there will be a variable space. By default, cursor will be there in the variable space. If not, then you have to click on variable space. After that you have to double click on average handling time. You will see that the average handling time will be displayed in the right side of the variable space. After that you have to click on OK. You will get this graph. You can see the process is stable because all the data points are within the upper control limit and the lower control limit, or you can say all the data points are within the 3 sigma distance from the mean. Therefore the process is stable. Now we'll see the process capability. Again you have to go to Stat tab, and then you have to go to Quality Tools, and then you have to select Capability Analysis. After that you have to select Non-Normal. Once you have selected Non-Normal, a new window will open. and where you will see the average handling time will be displayed in the left side of the window, and in the right side of the window you will see the single column space. By default the cursor will be there in the single column space. If not there, then you have to click on single column. After that you have to double click on average handling time. You will see that average handling time will be displayed in the single column space. After that, in front of fit distribution you have to select variable, because you have selected here the variable distribution. Therefore here also you will select the variable distribution. After that you have to enter 9 in the upper spec space, because 9 is the USL, and after that you have to click on options, and where you will enter 7 in the target space, because 7 is the mean time or the average time. After that you have to select the benchmark Z sigma level. After that you have to click on OK, and then again you have to click on OK. You will get this graph, and in this graph you will see the Z-bench value, which is 0.75. That means the process sigma or sigma level value is 0.75. Now if you want to analyze the process capability, then you will see the PPK value, which is 0.25, and PPM value, which is greater than USL, is 2 lakh, and PPM value total, which is 2 lakh. That means out of 1 million, 2 lakh calls can go beyond USL, and PPK value, which is 0.25, which is less than the generally industry accepted guideline, that is 1.33. Therefore we can say that the process is not capable of meeting customers' requirement. Let me tell you that to get these graphs which I have shown in this video, for this particular example you have to use Minitab software, and you have to follow the steps which I have written in the right side of each graph. So this is all about process capability analysis for continuous non-normal data. I hope you like this video. If you like this video, then don't forget to subscribe it by click on the bell icon. Add your valuable comments and share this video to your friends and colleagues to improve and refresh their knowledge. We'll see you in my next video with another topic. Have a good day.